Hi folks, let's solve minimum degree of a connected tree in graph. So it's actually a hard problem. The idea is very simple, but the limitation of time is very strict. So let's say how to implement. Like here I provide two solutions. If you haven't read this problem, you can take some time to read it. So the function signature looks like this. First, I define the graph as a vector of unordered set. Since it's a vector of unordered set, it's somewhat a complex data structure. So this solution is quite slow. I initialize answer as integer maximum. According to the problem, if it's still an integer maximum here, which means I didn't find any valid solution, so I just return -1 here. Otherwise, I just return my valid answer. First, I need to define the first point, the first node. So I just iterate all my n nodes. Then I get the neighbor of my node I. Okay, here I did a little bit optimization. If the degree of A is already greater or equals than my answer, I can just skip it. Okay, now I need to choose the second node. I just iterate the neighbors of node I. Okay, I did same. If the degree so far is greater or equals than answer, I can just skip. Here, I also apply another optimization. If B is smaller than I, then I can skip it. Imagine it. If currently I is 5, B is 3, then we don't need to calculate again. Since B is 3, which means when I is 3, I already calculated it. So I can just skip this case. Okay, now I need to choose my last node, C. I just iterate the neighbors of B. Okay, if C is also a neighbor of node I, the first node, which means it's a valid triangle, I just try to update my answer here. Okay, this is the first solution. It's quite slow. It did pass the test case, but it's quite slow, like 1.5 thousand millisecond. So let's improve a little bit. We can use like a adjacency metric to represent my graph so that we don't need to use this complex unordered set. Okay, let's take a look at solution second. Here I use adjacency matrix. So we get rid of unordered set. And I also need to define degree here. Okay, here I initialize my graph and degree. Okay, the answer is same as before. It's also same as before. For the first node, I just try all n solutions, n possibilities. Okay, here's a little bit optimization. If degree of I is smaller than 2, I just skip it. Also, if the degree of the first node is too large, then I can just skip it. Then I need to choose my second node. For the second node, I can just start from I plus 1. Okay, it's same. If the degree of second node is less than 2, I just skip it. If ij is not connected, I skip it. If the degree so far is too large, I skip it. It's all about optimizations. Okay, now I need to choose my last node. For the last node, I just start from 3 plus 1. If the degree of last node is smaller than 2, I skip it. If the last node is not connected with the first two nodes, I skip it. Then I update my answer. Okay, for the second solution, it's quite fast. It only takes about 260 milliseconds, since it all uses very simple data structures. And it also skip a lot invalid cases, which means like we terminate very early for some cases. Okay, that's it. Thanks.